Okay, what we'll do now is we'll take a look at properties 3 and 4. 3 and 4 and 5, as you can see. So we'll work our way through these. Now property number 3 states that perpendicular bisector of a chord, a line that passes through the center of a circle and is perpendicular to a chord bisects that chord. Splits it in two is what we mean by bisecting a chord. So let's explain what those words mean. So a perpendicular bisector means that we're taking this chord and we're splitting it in half, and indicated with these notation marks. Now that we know that if it's split in half, then each of those lines are now 5 units. And a line that passes through the center of a circle is perpendicular. So if it does pass through center, as this one does, we know now that this angle created is perpendicular. And perpendicular means that it forms a 90-degree angle. So if we look at some key ideas with this property, we know that the perpendicular bisector of a chord passes through the center of a circle. And that's important because we know that it's going to split the chord in two, which we've stated 5 and 5. But we also know that it's going to create a perpendicular angle, but more importantly, it's going to create a radius. So now if we knew the diameter, if we knew, for instance, that the diameter was 12, we would know that this radius, I'll indicate here with red again, this radius would be half of that distance, which is 6. Okay? The perpendicular bisector of two distinct chords intersect at the center of a circle. So we also know that we have a central angle here. All right. If a bisector of a chord in a circle passes through the center, then the bisector is perpendicular. So indeed, if it does go through center, then we know that if it does go through center, I'll state that again, and it bisects this chord, then we have a 90-degree angle there. If a line passes through the center of a circle and intersects a chord at right angles, then the line bisects the chord. The shortest path between the center of a circle and a chord is a line that is perpendicular to that chord. So just those key ideas here are just summarizing those important points that if it comes through center, bisects the chord, we have a right angle. If it's a radius and it's perpendicular, we know that it's going to bisect this chord. So if one statement is true, then we know the other is true as well. So let's take a look at property number 4. Tangent to a circle. Well, we need to know what tangent to a circle means, and then we could check our definitions on that. But this is a line of tangency that we're indicating right here, and the point where it touches the edge of the circle, because it can only touch on one point, is our point of tangency. Okay, because we could see that if we were to draw a line through there, that we would be touching the edge of the circle at 2 points, and that is not a line of tangency. So I'll erase that. Line of tangency is when it touches only at 1 point. A tangent to a circle is perpendicular, which means it creates a 90-degree angle to the radius at the point of tangency. So we know that a line, the key word there is that the radius. So if we have a line coming from center, which has to be a radius, and it touches the line of tangency, that this creates a 90-degree angle. And the key ideas here is that a line that touches a circle at exactly 1 point is the tangent to a circle, and point B is known as the point of tangency, as explained earlier. Now if we take a look at property number 5, this is also talking about tangents. Tangent chord relationship, which a chord drawn perpendicular to a tangent at the point of tangency contains the center of a circle and is the diameter. So key ideas here are that line AB is tangent to a circle. So there's our tangent line of tangency. There's our point of tangent. And is perpendicular to the radius. So we know that we have a 90-degree angle created right here. A chord drawn perpendicular to a tangent line at the end of the tangency contains the center of the circle and is the diameter. And we also know that we have a diameter which goes the distance all the way through. So we know that if we have this line of tangency and it forms a 90-degree angle right here, that this would also be our diameter. And the reason that is important, if we know that this is our diameter, we can go back to property number 2 and see that we have an inscribed angle right here, and that this diameter means that it must have 180 degrees. sorry about that, 180 degrees. We'll do that again. And that means that our inscribed angle is half of that distance, which is going to be 90 degrees. I hope you found that helpful, and I appreciate your time. Thank you.